All right, so this last application is going to get into distance, rate, and time relationship. So we got three variations of the formula that we could possibly use. So we had distance equals rate times time, or we could solve the formula for other variables. So if we solved it for r, we would get distance over time, and then the third case, time would equal the distance over the rate. So depending on the situation, you would use the appropriate variation of the formula. So let's take a look at the first one, time saved. How much time is saved traveling 50 miles if someone is traveling 55 miles per hour versus 65 miles per hour? Round your answer to the nearest minute. Okay, so this is kind of good for your speeders out there. Know how much time are you really saving if you're speeding. So let's see. Now we're trying to find the time saved. So really this first version and second version isn't going to be helpful. This third one though, how much time is saved. So let's use that version of it. So let's start with the 55 mile per hour case. So if we want to know the time that it takes to travel 50 miles, so remember we want d over r. So the distance is 50 over the speed, which is 55. So rate is the speed. So we get what? Well, let's get our calculator out. So we got 50 divided by 55 equals 0.909090. Now the one thing to keep in mind is that that's in hours. So if we want to change this into minutes, well, how many minutes in an hour? Yeah, 60. So really all we have to do is just times this by 60. And that will tell us how many minutes. So we got 54.545 minutes, which if we round it to the nearest minute, well, let's leave it like that for now. We'll round at the very end. Okay, so now let's look at the 65. So we're still traveling the same 50 miles, but now we're going 65. So let's see what that does. 50 divided by 65 equals 0.769 blah, blah, blah hours. And we want to change that into minutes. So let's times that. Oops, not times, divided by times. I'll get it right, folks. So 46.1538 minutes. Okay, so there's our two answers. So how much time is saved? So we got to subtract those two to finish it off. So the answer would be what? So we want 54.545 minus 46.15, and let's round that to a 4, equals, so 54.545 minus 46.154 equals 8.391. So rounded to the nearest minute would be 8 minutes. Saved. So, but that's going 50 miles. And that means you're going that speed from the moment you put your foot on the gas pedal to the moment you get there. And that doesn't happen. So more than likely you're not saving 8 minutes. You're probably saving less than that. So my point is, you're not saving a lot of time if you speed. You know, I mean, if you were going 90 miles an hour, of course you're going to save some time, but hopefully you're not doing that on the road. So and most people are not traveling 50 miles. If you're commuting to the college, probably commuting less than, 20 miles, so 20, 25 miles. So you're even saving half of that, and even less than half of that. So really, it's not going to be to your benefit if you speed a short distance. So something to think about. All right, let's try our standard distance problem that I'm sure you've seen some in your history. A train leaves Little Rock, Arkansas and travels north at 85 kilometers per hour. Another train leaves at the same time, travels south at 95 kilometers per hour. How long will it take before they are 315 kilometers apart? Yay! Well, we can still use this table to get our equation. So, rates. Rates are your speed. So, our speeds are here. We got 85 and 95. So there's our speeds. The time is something we don't know. How long will it take before they are 315 kilometers apart? So the only thing we really know is that one's going north and one's going south. All right, so let's just draw a little diagram here. So we got, okay, here's the train station. One's going north at 85 and one's going south a little faster at 95. But we want the entire distance to be 315 kilometers apart. So we're starting the clock at a specific time, and then we stop the clock at a specific time, and that applies to both trains. So if one train travels 2 hours, the other train's traveling 2 hours, and then we add those distances together. So that's important. The time is the same for both of them, but we don't know what it is. So let's use a variable. Let's call it t. So t is the time traveled by either train. So now we have a quantity that we can use. So if we have our rate, we have our time, what's the distance that this train travels? How can we find it from an equation? All we got to do is multiply. All we got to do is multiply. So let's multiply 85 times t and 95 times t. So this is the distance the north train travels. This is the distance the south train travels. What's the total distance we want them to travel? 315. So here's the makings of our equation again. So we got 85t plus 95t is 315. Nice, easy equation to solve. So it looks like we're going to get 180t equals 315. Let's divide out the 180 and let's make sure we get it right. So 315 divided by 180 equals 1.75. So 1.75, and then what would the units be? We're talking about time. Everything was in kilometers per hour, so it's going to be hours. Now, if you wanted to be fancy and put it in hours and minutes, you can, but you don't have to. So 1 hour and 45 minutes. So, all right. So that wraps up this section. Breathe. Try your best on it. Don't freak out if it's not your perfect grade or anything like that. This is a tough section, so keep that in mind. More stuff to come in the next section. See you soon.